Good morning. This is your stats sensei, Mr. Spensei, and this is our test review. Hope you make it through the video. I hope this will be very helpful to you. The following, the population mean and standard deviation for the GPA of all non-traditional students is 3.5. Suppose that a random sample of 100 non-traditional students is selected from the population of all non-traditional students. So we have a mean of 3.5 and a standard deviation of 0.5. And they're telling us we have a sample size of 100. So n equals 100. Draw a graph illustrating the empirical rule for the distribution for the GPA of all non-traditional students. You must show 3 standard deviations above and below the mean. Clearly label the z-scores and the actual values. You must show the standard deviation. All right, so first off, let's start with our z-scores because that's the easiest. So 0, 1, 0, 1, 2, and 3. And then, of course, -1, -2, -3. Please remember, it goes to positive infinity and it goes to negative infinity. Now, they also asked us to show our the empirical rule. So if we're doing the empirical rule, we got to include the plus or minus 1 is 68%. The plus or minus 2 is 95%. And finally, our plus or minus 3 is 99.7%. All right. They told us our mean was 3.5. And it said our standard deviation is 0.5. Now, please, we need to look at this real carefully. Did it say the sampling distribution? It didn't, so this is just 0.5. We do not have to make any division. So this is 0.5, and this is 0.5. This is 0.5, 0.5, and 0.5. All right, so this is 4.0, 4.5, and this is 5.0. This is 3.0, 2.5, and then this is 2.0. All right. So that takes care of everything there, except I need to put a little mu for our mean. So that takes care of the first one. All right, and that's just a continuation of what we've been doing. All right, number 2, 76% of the students will have a mean GPA that falls within what interval centered about the mean? First off, they gave us a percent. So since they gave me a percent, I'm going to think that this is an inverse norm. The other thing is we know that the distribution is normal, and so we need to go ahead and draw the normal curve. So there's my normal curve. Got a little flat there on top. And we know that the mean is 3.5. But what we're looking for is this middle part. And they told us this middle part needed to be 76% or 0.76. So we go to our calculator, and our calculator commands are going to be inverse norm. The very first thing it's going to ask for is our area, which is 0.6. That's the 76%. The mean is 3.5, and our standard deviation happens to be 0.5. And we're going to, the next thing it'll ask is left, center, or right, and we're interested in the center. So let's go to our calculator. Second vars, inverse norm. And our mean, our area was 0.76. Our mean was 3.5. Our standard deviation is 0.5, and we wanted the center. And when we do that, we end up getting a lower bound, because this is what we're looking for, is this lower bound and this upper bound. So we have 2.9125, comma, 4.0874. And we're going to label that lower and upper. All right, so that takes care of our number 2. Number 3, suppose that 100 randomly selected students, shouldn't say bottler, randomly selected students from the population. All right, so we've randomly selected 100 students, give the mean of the sampling distribution of X bar. So they want the mean of the X bar, and they say sampling distribution, And this either needs to say X bar, mean, or average. In this case, it says the average. Well, the mean is the mean is the mean, so that's easy. The mean is just going to be 3.5. That's our GPA average. But then it asks for the standard deviation of X bar. Well, the standard deviation of X bar is the standard deviation of the population divided by the square root of n, which in this case is 0.5 divided by the square root of 100. And that's 0.5. The square root of 100 is 10. So in this case, 0.5 divided by 10 is 0.05, or 0.5 divided by 100 raised to the half power. So our standard deviation of X bar is 0.05. All right, number 4. What is the probability that a randomly selected student has a GPA between 3.7 and 3.9? So, once again, we're looking for a normal. So let's draw our picture, because it might help us remember what we're supposed to be working with. So our mean is 3.5. Well, we want a GPA between 3.7 and 3.9. Well, 3.7 is above 3.5, and so is 3.9. So I'm looking for this area. Now, and this is the case, we know they didn't give us a percent, so we're not working with a inverse norm. So we know we're not working with that. The question is it going to be a z-test or a normal CDF? Well, it's because it's a single student, then we are probably going to be working with a NormCDF. If it have been multiple students, we are probably going to be working with a z-test. So this is going to be a NormCDF. Lower bound is 3.7. Upper bound is 3.9. The mean is 3.5. And our standard deviation is 0.5. So lower, mean, upper, lower, upper, mean, standard deviation. Lower, upper. All right, so let's run this on a calculator. Second vars, normal, CDF, lower bound 3.7, upper bound 3.9, mean 3.5, standard deviation 0.5. And we end up getting 0.1327, and we want 4 decimal places. All right, number 5. What is the probability that a 100 student sample has a mean GPA of less than 3.41? So let's go ahead and draw our curve. We're all centered at 3.5. 3.41 is below that. And it goes to negative infinity. Now, one thing it says is, first off, it doesn't say anything about a percent. So now we know we're working with the norm. So that gets rid of inverse norm. And then we need to decide between a z-test and a NormCDF. But it gives us a 100 sample, and they ask about the mean. So this is going to be a z-test. And the first thing it's going to ask me for is the mean. Well, the mean is 3.5. Our standard deviation is 0.5 because that's the standard deviation of the population. It's going to ask me for my X bar, which is the average, which is 3.41. It's going to ask me for my sample size is 100. And since it says less than, we are shading to the left. So that's our calculator commands. Stat, test, z-test, mean 3.5, standard deviation 0.5, X bar 3.41. Sample size 100. We have the less than selected, calculate, and we end up getting 0.0359. So 0.0359. All right, number 6. What is the probability that the average GPA for a sample of 23 students is greater than 3.7? All right, so this is going to follow the same rules as the last one. We're going to draw our graph, but we'll notice that it doesn't say anything about a percent. It gives us a sample size, and they talk about average. So that tells me it's going to be a z-test. Well, we know 3.7 is above 3.5, and this will go to infinity. So we're going to go ahead, and that's our drawing, and we have z-test. Our mean is 3.5. Our standard deviation is 0.5. Our x bar is the 3.7. Our sample size in this case was 23, 23, and we shaded up and to the right. I want to rewrite that. That should be 23. So let's go ahead and run that. So stat, test, z-test, 3.5, 0.5, 3.7 is my x bar. My sample size is 23, and we need to make sure that we're shading up and to the right. And we get 0.0275, all right, so 0.0275. Finally, number 7, what are the z-scores associated with the middle 89% of the data? Well, they gave us a percent, so this lets me know I'm working with a inverse norm, and they're talking about the middle. So the middle means that I'm shading like that. All right, and they gave me this, so it tells me an inverse norm. So inverse norm, the area is 0.89. I'm going to rewrite all that. This looks horrible. So inverse norm, the area is 0.89. The next thing it's going to ask me for is for the mean and for the standard deviation. Well, we got to be very careful here. This says z-scores. All z-scores have a mean of 0 and a standard deviation of 1. So mean is 0, standard deviation is 1 because it's a z-score. And we're looking for this lower and upper bound. So when it asks me for a mean, I'm writing 0. It asks me for the standard deviation, I'm writing 1. And then we want this on the center. All right, so here we go. Second vars, inverse norm, area, 89%, so 0.89. Mean of 0, standard deviation of 1, we needed it centered. We end up getting negative 1.598 and 1.598. So negative 1.5981 and 1.5981. This is my lower bound. This is my upper bound. This is my probability. This is my mean. This is my standard deviation. All right, so that takes care of scenario 1. So we're going to go ahead and quickly move over to scenario 2. A survey is planned to determine the mean monthly family lodging cost of employees of a large company. The population lodging cost is $3,550. This should say the population mean lodging cost is $3,350. So mu is 3,350 with a standard deviation of $773. All right. Suppose a simple random sample of 143 employees is taken from the over 23,000 employees at the company. Give the mean lodging cost of the sampling distribution of the means. Well, the mean is the mean is the mean, so that's easy. The mean is 3,350. The standard deviation of X bar is the standard deviation of the population divided by the square root of n, which in this case would be 773 divided by, we have a square root of 143. So stat, test, 773 divided by 143 raised to the half power, or the square root of that. And I end up getting 64.64. So my standard deviation of X bar is 64.64. Now, this is a mistake. This is done correctly, but I did not mean to make ugly numbers. Sorry about that. Number 9, what is the z-score associated with the bottom 6%? Well, first off, it's asking for a z-score. So with a z-score, we know the mean is 0, the standard deviation is 1. Secondly, they gave me a percent, so this tells me I'm working with an inverse norm. So inverse norm 0.06, mean is 0, standard deviation 1. And we want the lower half, so we're shading from the left. So second vars, inverse norm, area 0.06, mean is 0, standard deviation 1. Make sure it's on the left. And we end up getting a negative 1.554. So this is what we found, is we found this z-score, and it should be negative because we are below 0. So negative 1.5547, taking it 4 places. And that's my answer to that. All right, number 10. What is the probability that a sample of 75 employees has a mean lodging cost of 700 of less than 3,200? All right, so we need to go back and look at our mean. Our mean was 23,000. And our standard deviation was 773, because we're going to need that number. So the mean is 23,000. And oops, excuse me, I'm sorry about that. The mean is not 23,000. The mean is 3,350. So this is my mean at 3,350. And we want to know the likelihood that it's less than 3,200. But we have a sample size 75, so this lets me know we're working with a z-test. And the first thing it's going to ask me for is my mean, which if I write it correctly this time will be 3,350. We have a standard deviation of 773. We have a X bar of 3,200. And we have a sample size of 75. And we ended up shading to the left. So, stat test, z-test, mean 3,350, standard deviation 773, X bar 3,200, sample size 75, shading to the left, and we end up getting 0.0464. So the probability that it's less than 3,200 for a sample of that size would be 0.0464. What's the probability that lodging cost exceeds 4,350? All right, this was unclear the way this is phrased, and I apologize for that. So let's go ahead and adjust this. So 3,350, that's easy. This is 4,350, and it should say for an employee or for a house, for an employee. An employee is just one. So this means this is a NormCDF. The lower bound is 4,350. The upper bound is positive infinity. The mean is 3,350, and our standard deviation is 773. Lower, upper, mean, standard deviation. Second vars, inverse norm. Second vars, NormCDF. Lower bound, 4,350. Upper bound, 9 to the 99th. Mean, 3,350. Standard deviation, 773. And we get 0.0978. All right. 9% of all lodging costs will be below what? All right, we have to be really careful. First off, this says what? So anytime it says that, we put an X. Well, 0.09 is below X, so that tells me where I'm drawing. And in this case, we have a mean of 3350. We're on the lower side, so down here, so 0.09, but they gave us a percent, so this is an inverse norm. Inverse norm. Area is 0.09. Mean 3350. Standard deviation 773. We're coming from the left. Second vars, inverse norm 0.09. 3350. 773. And we get $2,313.59. $2,313.59. And what that means is the bottom 9% is paying less than that. Lower upper, not lower upper, probability, mean, and standard deviation. I want to run something real quickly. That test. I'll go back and check this out real quickly. Sat test, d-test. Oh, no. Second vars. NormCDF, excuse me for just a second. I'm going to run back something real quickly here. This was number 11. I just want to run it one more time to make sure that we actually did this right. The lower bound was 4350. The upper bound was 9 to the 99th power. The mean was 3350 and the standard deviation was 773. Yes, we did 0.0978. All right, number 11 is good. Number 13. 64% of the lodging costs are above what? First off, this is over halfway. So, all right, so this means we're gonna have more than 50%. But it says above what? So we have an X, and so 0.64. So we're shading from the right this time. But please remember, we're gonna go over halfway because it's 64%. So 3350. This is 0.64. They gave us a percent, so this is an inverse norm. And we're going to have an area of 0.64. We're going to have a mean of 3350, and we're going to have a standard deviation of 773. This is my probability. This is my mean. This is my standard deviation. And we're coming from the right. All right, we're coming from the right because we shaded on from the right-hand side. All right, so second vars, inverse norm, 0.64, mean 3350, standard deviation 773, coming from the right. And we get 3,072.91. 3,072.91. All right, last thing. Draw a graph illustrating the empirical rule. All right. You must show 3 standard deviations above, et cetera, et cetera. But they want the sampling distribution of the, it should say mean lodging costs. So let's make that change, sampling distribution of the mean lodging cost. So in this case, we're going to start with our z-scores, 0, 1, 2, 3, -1, -2, -3. That's 68%. This is 95%. This is 99.7%. And we're going to go back and look at 8 real quickly. On 8, it said lodging costs was $64.64. We're just going to call that an even 64 to make our life a little bit easier. But still, I won't give you a number quite that ugly on the test. I'll go back and check to make sure that didn't come out wrong. So our standard deviation is 64, 64, and 64. And going this way, it's also 64, 64, and 64. Our mean was 3,350. That's our mean. So we're going to just start adding 64 to 3,350. So 3,350 plus 64. So 3,414. I'm going to add 64 again. 3,478. And once more, we're going to add 64 again. So 3,542. All right, we're going to go back to the 3,350 and start taking away. 3,350, take away 1 standard deviation. Is 3,286. We take away another standard deviation. That's like taking away 2 standard deviations, minus 64. Because there's the, oops, plus 6. Minus 64. That's 3,222. And we take away 1 more, which is minus 64. And we get 3,158. All right. Hopefully that helps you out. I'm sorry for the few mistakes, and I hope your test goes really well. See you on the next one.